Okay, so your first thought was very good, Jake. You said, okay, I have no graphs to look at, so to figure out when f is decreasing or f is increasing, or to figure out when f is concave down or f is concave up, I got to do a sign chart. So remember the first rule of, well, one of the big rules of a sign chart is no sign chart until I have Danica's chart. So what are you focused on? For this Danica's chart, where should your eye be focused, Jay?
Where it changes from positive to negative?
Yeah, the whole idea is I want to make a sign chart. So I should be paying attention to the signs on Danica's chart, not the other stuff. So here's one sign chart I could make. What would that blue sign chart tell you, Jay?
If it was f is increasing or decreasing.
Perfect, which I need to know over here. You know, f is decreasing, f is increasing. Then I'm going to focus on this portion of the Danica's chart, and that will tell me what, Jay?
If f is either concave up or concave down.
Perfect, if f is concave up or concave down. So that's the idea, is that I'm looking at this maroon correspondence, and I'm also looking at the blue correspondence. Anybody else want to talk about that? Okay, so we have our Danica's chart, which should lead us to the sign chart. Can't make a sign chart unless I know what I'm charting. So what do you want to make a sign chart of, Jay?
Well, you'd want to make a sign chart for both f prime and f double prime.
Perfect. So let's start with the sign chart for f prime. So what's the first thing we would do to make the sign chart of f prime?
You'd have to figure out where it's equal to 0 or undefined.
Perfect. So what values of x will cause f prime to equal 0 or undefined? Now here's a huge hint. When you see a fraction, deal with the top and bottom separately. Don't do them together, ever. So just look at the top. Tell me what makes the top either 0 or undefined.
I couldn't tell you, that's what I didn't know.
I think that's why I'm stuck. So you need a flashcard. Your flashcard should have like this on one side, and then on the back side it should say this. I have the world's largest supply of blank flashcards, so don't ever hesitate to ask. I'm not kidding. I have the world's largest supply of blank flashcards. I mean, not the world's largest, but I challenge you to find a teacher who has more spare flashcards than I have. So. Anybody else need some? Okay. So this is really good because that's what happens is in calculus is an iterative process. Like you learn, you take a test to see how well you learn, and then you try to find the holes. So Jake has found a hole, and it was the missing hole that makes it so you can't solve the problem. So we're hoping that once we fill in the hole, he's like, oh, I can do this now. So looking at f prime, we're trying to find the zeros or undefines of f prime. So again, we look at top and bottom separately. So Jake, can you tell me what values of x will cause the top of, I guess it's ln of x, either be 0 or undefined?
Well, if x is e to the 0 at the top, and it'd be 0, and it would be undefined because 0 on the bottom, because anything divided by 0 is undefined.
True. The other one to not forget, so I'll say it again for the video. Now, I wrote e to the 0 here because I was trying to get you to see the pattern. The natural log of e to any exponent is just the exponent. You won't typically see e to the 0. You're more likely just to see 1, because e to the 0 is 1. So I know that if I plug in a x equal 1 here, this will be 0, this will be 1. 0 divided by 1 is what, Jake? 0. So that is a 0 of f prime. So here's my x values of f prime. Here's my y values of f prime. When x is equal to 1, f prime is definitely 0. The other one you said also works, that if there's a 0 on the bottom, if x is equal to 0, two problems there. The natural log of 0 is undefined. The natural log of any negative is also undefined. So all of that needs to be on your flashcard. So put a big U right there. They want to talk about anything. So now what, Jake?
Then I have to get the plug-in values on both sides of where you found that x was 0.
Very good. So I've got to test the gaps. So what x value would you like to test with?
2.
So 2 belongs where on this number line?
To the right of 1.
Good. Choosing 2 makes sense because it is larger than 1. What doesn't make sense is I'm going to plug 2 in here. I'll get the natural log of 2. Do you know the decimal equivalent for the natural log of 2? I don't either, so I don't want to choose 2. I want to choose something that when I plug into ln, I'll be able to get, move forward.
So you could do e to the 2.
Perfect. E squared works. Is e squared larger than 1? You got to make sure you got that right.
Yes.
How do you know?
Because e to something, the e to something that equals e to the second is 2.
Not a real good reason why it's bigger than 1.
Well, that's what the natural log means. It's like e to the what equals.
Well, that's true. But I'm asking, you're doing great. I'm just asking a different question.
Okay, I guess that's true.
You're good. We're picking an x value that we are going to plug into here. And a good choice is e squared because the natural log of e squared is going to be 2. That's awesome. I got to make sure that e squared belongs here, doesn't belong over here. How do you know that e squared, when x is e squared, it belongs here? Go ahead, Elizabeth.
Because doesn't e equal like 2.7 something?
So 2.7 squared, definitely bigger than 1. Perfect. So that's why, that part actually is critical. I've seen people, again, it's calculus, right? All it takes is one slip up. Megan's like, oh yeah. That's all it takes, right? One mistake, suddenly you miss the whole problem. And it's not because you didn't understand most of it, it's like it's all it takes. So definitely e squared is good there. So Jake, put an e squared here, the top's going to be
2.
and all we care is positive. Bottom's going to be
2.7 squared.
and all I care is whether that's positive or negative. Yep, the bottom's 2.7 squared, that's positive. Hence a positive divided by a positive is a positive. So these are positive. We want to talk more. So now what, Jake?
Then you'd have to find the value between the x values of 0 and 1.
Okay, you did a really good thing right there. I want to highlight it. We are looking for x values between 0 and 1. Be very specific. Your scores will go up. I guarantee it. When he said x, that's crucial. Looking for x between 0 and 1.
You also want one that is easy enough to use with natural log of x.
Yeah, I need something that when I plug in the natural log of x, I can deal with it. So what are you going to pick?
Because the only thing I can think of would be, no, because that's even, I don't know.
Somebody help me. So you're all hitting the blind spot here. That's okay. That's what we're here for, is to find the blind spot. Christine. Because e to the negative 1 is the same as what? 1 over e. What's e, Christine? So 1 over e is about 1/3. Jake just suddenly realized that 1/3 fits rather nicely between x equals 0 and x equals 1. So plugging in 1 over e works great. So Jake, what's the natural log of 1 over e?
Negative 1.
Good. All we care is the sign, so negative on the top. The bottom, will the bottom be a positive or negative value?
No, it'd be positive.
Why?
Because even if, because no matter how, well, let's see how that explains. Because something over a positive, because like we said it was 1 over e, right? And e is 2.7, so it's a fraction. It might be really small, but it's still positive.
Yeah, it's not even that small. 1 over 2.7 is about 1/3. So definitely positive on that. Definitely, I didn't say it. Definitely positive on the bottom. Hence negative here. We don't want to talk about any of that. So now what do we know, Jake? I feel like I'm in the State Farm commercial. Sorry. That was decent. That was decent.
So
What do we know,
now
Jake,
we know
from
that
State Farm?
from x values of 0 to 1, f is decreasing, and for the x values above 1, it's increasing.
Perfect. Perfect. So which answers are still valid?
So C and D.
Nicely done. It's a really good problem to talk about because we've hit a lot of holes. Anybody else? Question? So now what, Jake?
So then we have to do another sign chart for f double prime.
Yep. You're talking. Better that you talk and I don't.
And so f double prime is equal to 1 minus the natural log of x over x squared. And so we have to figure out values that would make that equal to 0 or be undefined.
Nicely said. I'll say it back for the video. So we're going to chart f double prime because over here we're trying to figure out when f is concave up or concave down. Therefore, we must figure out what values of x will cause f double prime to be 0 or undefined. Because we have a fraction, we can focus on the top and bottom separately. Keep going, Jake.
And so, because the top of it is 1 minus the natural log of x, we know that the natural log of e is 1, and 1 minus 1 is 0.
Perfect. So if I plug in an x equal e, the numerator becomes 0 because the natural log of e is 1. 1 minus 1 would be 0. The bottom would just be e squared, which is positive. 0 over positive is definitely 0. Keep going, Jake.
And then we still need to find, well, and then if we put in 0 on the denominator, that's undefined.
Yeah, 0 on the bottom is definitely going to cause this whole thing to be undefined, this whole f double prime. 0 also causes the natural log of x to be undefined, so 2 reasons why 0 is a problem. Good? Cool. Keep going, Jake.
Okay. And then we need to test values in between those again that we can still test with the natural log of x. So we have to do like e to the third to get a value above e.
Yeah, e squared would work too. You know, because e is 2.7, e squared is going to be bigger than that, or e cubed is fine.
Well, but aren't we trying to find what the natural log of it is too? Because
Oh, you kind of struggled with this a minute ago. Let's talk some more.
because
No, stay here, stay here,
what I'm
stay.
thinking about, like,
Keep going.
so we're just trying to find an x value above e, not necessarily an x value above e that already went through the equation for f double prime.
Right, because remember, this sign chart is it's just a number line. These are just different values of x in order. And so this is 2.7. I could test 3. Which doesn't help because I don't know the natural log of 3. I can test e cubed because what is the natural log of e cubed? 3. See the difference? Cool. So we plug in e cubed. The top will be positive or negative.
Negative.
Yep, because you'll have 1 minus 3, which is negative. The bottom would be because
Because e is positive and e to the sixth is still positive.
well done. We're plugging in e cubed. That's a positive value. Positive value squared is still positive. My focus is only on the plus or minus. I don't care about numbers. So that means, what do I put here? Negative. Go on, Jake.
And then we need to find the value, an x value in between 0 and e.
Oh, Zach, please talk.
Could you just put 1 over e in between 0 and e again? Because it's like close to 1/3.
Because e is about what?
2.7.
2.7. Perfect choice. Say again.
Could you also just do 1?
For sure. Because e is 2.7. So 1 is definitely less than e. Both of those values, when plugged into natural log, I can deal with it. So I'm okay with that. Perfect. Keep going, Jake.
Okay, and then when you plug that into the, well, we already know this. So when you put that into the top part of f double prime, you get -1 for what the natural log of x is, and 1 minus -1 is 2, which is positive.
Good. So I plug in 1 over e. The natural log of 1 over e is -1. 1 minus -1 will be a positive value. In the bottom.
And then we know it's a fraction that's positive, and a positive times positive is still positive.
That was a perfect way to think through that. It's perfect. 1 over e is positive. That's all I care. Positive squared is still positive, so this is positive. So now what, Jake?
So now we know that So now because of Danica's chart, when f double prime is positive, we know that f is concave up for all values that x is greater than e, and also in between the x values of 0 and e. Well, no, I wrote wrong. It's concave down when it's greater than e, and then it's concave up between 0 and e. Sorry.
Good. So which one is correct?
So it's concave down for x is greater than e, because the x value is greater than e is concave down.
So when x is greater than e, f double prime is negative, Hence F is concave down, and C is the correct answer. Good work. Well done. Well done. Good work. We have a different thing you want to talk about.